So now we're going to use this idea of the initial value, specifically the initial length of the rubber band, to construct an algebraic model in science. This again is basically the idea of y equals mx plus b, but we need to use the variable names of the things that we're actually graphing. One clue here is pay attention to the difference between a variable name and a unit. This is still important. Looking at EA2 could be helpful here. EA2, remember, is on page 53, so you want to write that in here. A slope and initial value are specific numbers, so they'll need correct units, but a variable name doesn't get units. We'll see that very soon. Let's start by just writing down the main idea here. The main idea is to do y equals mx plus b with correct variable names from the graph or from whatever it is we're working. So like, for example, if we're again graphing the length in centimeters and the mass in kilograms, I'm going to use the same numbers from what we had on EA16. We're going to say, what if the initial value is 39 centimeters, for example, and what if the slope here is 24 centimeters per kilogram? We want to use these pieces of information to make our algebraic model, to put into y equals mx plus b. But in this case, for this example, the y-axis is length. That is, we're going to think of length as the variable name on the y-axis, and the x-axis is mass. So we need to use these two variable names in our algebraic model, and that looks like this. Instead of writing y equals mx plus b, we write length, because length's on the y-axis, equals 24 centimeters per kilogram. That is the slope. So we're dropping in slope for m, times the mass, the variable name that's on the x-axis, plus that initial value, 39 centimeters. We are using all of these pieces of information just like we would with y equals mx plus b, but we're not writing y and x. We're writing the actual variable names. So we want to remind ourselves we are not just writing y equals 24x plus 39. Even though this would be okay to do in math class, even though this would be a great algebraic model in math class, except we probably would want units in these, maybe, or to finish our answer with units, it's not enough for physics class. So I'm going to put a box around this to say this is what we are trying to do. Notice, this number, mass, doesn't have units. But this number has units. That's this clue right up here. The slope and the initial value, they have units, but the variable names don't have units. So make a note to yourself to remind yourself that the variable names do not have units. I could even add this here. No units there. So one last note that we want to keep in mind here. First of all, just to remind ourselves of that thing that we just wrote down, the slope and initial value numbers have units, but variable names have no units. For example, And this could be we could call this our general equation. We start with length equals 24 centimeters per kilogram times mass plus 39 centimeters. Then we substitute with units. So length equals 24 centimeters per kilogram times some value for mass. So for example, what if I was predicting for 2 kilograms? I would substitute 2 kilograms for mass plus 39 centimeters still. My kilograms would cancel out, and I would end up with length equals 48 centimeters plus 39 centimeters equals 87 centimeters. So I want to remind you actually that we've done this before back in BFM 6 on page 20. We have a lot of practice with this, general equations, substitute, and solve. Oops, I forgot to write solve here. So we want to refer to that as an example. Here we're making our own algebraic representation, our algebraic model, and then we're going to write that general equation, substitute, and solve to do our correct algebra just like we practiced before.